We've seen how we handle finding lengths and angles when we've got a right angle triangle. What happens if it's not right angled? And that's where we have these other rules, you may recall. And the first of all, one we would have seen would have been the sine rule. So here's just a standard triangle. So the normal notation is we use capital letters for the vertices. The side opposite, we use the corresponding lowercase letter. Now what I can do is I can drop in a perpendicular height and I create two right angled triangles. Because as I say, we know how to deal with right angled triangles. And I can say, well look, h over c, that would equal the sine of b. So therefore the perpendicular height is c sine b. But I could look at the other right angled triangle and say, well actually, the perpendicular height is b sine c. Well, it's the same perpendicular height. So therefore those two things must be equal, thus creating our sine rule. C over sine c is b over sine b. Now I get that formula because I dropped from A down to BC, but I could have just as easily gone from B to AC or C to AB. So the complete sine rule is A over sine A equals B over sine B equals C over sine C. Well, that's almost the complete sine rule. Does anyone know the other thing it's equal to? I might mention that later. So little h is what I want to find. So for this one, it'll be h over sine h is q over sine q. Subbing in, and it really is just a substitution rearrangement type thing. So now I multiply both sides by sine 5746, and it's all calculator work from there. Press the buttons, and we get, hopefully, 45.8 units to decimal place. And if we have to find an angle, so the angle I'm trying to find here is over here at y. Usually we turn the equation upside down, so what we're trying to find is on the top. So now I'll write it as sine y over y is equal to sine z over z. Substitute in, but before I can find y, I need to make sine y the subject. And again, a bit of calculator work. And we come up with 46 degrees 58. So they're really the two standard sort of questions we see with the sine rule. However, we have a problem with the sine rule because of course our calculator will only give us answers between 0 and 90 degrees. So what happens if that angle is bigger than 90 degrees? The calculator won't tell me because remember, sine is positive in both the first and the second quadrant. So it will assume, the calculator will always assume the acute angle. So we need to look at it and make sure, does the angle or does the answer make sense? It is possible the angle might be an obtuse angle. So things to look out for. Remember, angle sum of a triangle is 180 degrees. So if you know some of the other angles, and when you add in this angle and it becomes obtuse, you get an answer over 180, well then obviously it's not an obtuse angle, it must be an acute angle. But also keep this lovely thing in mind, the largest angle is always opposite the largest side, the smallest angle is always opposite the smallest side, and so on. So sometimes you can look at the other sides, compare them to the angles, and that will also let you know whether it's possible, whether the angle could be obtuse or not. Okay, here it is. There's a triangle, ABC. It is possible to draw a circle around any triangle. It's what's called the circumcircle. The diameter of that circumcircle is actually equal to A on sine A or B on sine B or C on sine C. That is the complete sine rule. So A on sine A is equal to B on sine B is equal to C on sine C, which also happens to equal the diameter of the circle that would go around that triangle. There you go. Seen something new today. Well, what about the area of a triangle? We can also use the sine function to calculate that if it's not a right angled triangle. I'm going to drop the perpendicular down. When I drop a perpendicular in, I could find the area of the triangle quite easily. I could go half base times height, which in this case would be half of A times the height. But then I need to work out what the height is. And I can use trig, so h is b sine c. If I substitute that in, I get my formula, half AB sine C. Again, I could have dropped that perpendicular from B to AC. I could have gone from C to AB. So, of course, it could also be half BC sine A or half AC sine B. It's always two sides and the included angle. That's how we can find our area. As long as we've got two sides, the included angle, we can do it. So a quick example of an area question. In this case, half dm sine f. And that works out to be 25.47 to 2 decimal places. Okay. 4h which would be a very hard pencil when you think about it. 2h is quite hard. 4h would be amazing. Okay.